Hello everyone, welcome to today's webinar. I am Niyati, Chief of Staff at VergeCloud, and we are so glad you're here. Today we are talking about Cloud DNS 101, what most teams get wrong about authoritative DNS, why registrar DNS is not the same as authoritative DNS, how Anycast routing changes the way your records resolve across geographies, what TTL decisions actually cost you during deployments, and how failover at the DNS layer works in a real production setup. Before we dive in, a quick word about VergeCloud. We are Bangalore headquartered, building India's own edge infrastructure company for CDN, DNS, and cybersecurity. Please feel free to drop your queries or questions during the webinar in the comment section, and team will address it. We will also have a dedicated Q&A session at the end of the speaker presentation. Now I would like to hand it over to our guest speaker and expert, Dheeraj and Arshad. Dheeraj and Arshad, over to you.
Sure, thank you. I hope I'm loud and clear. Let me start. So, Neeti, thanks for the introduction. As Neeti has mentioned, today's discussion will be about a deep dive into what is the cloud DNS, and it's not just about DNS, how modern DNS, edge-based DNS solutions are at the moment working, and why traditional registrar DNS falls short, or you could say where they are lagging. So that is what we'll be discussing about in today's webinar. And even on top of it, we'll be discussing about how in modern DNS architecture and traffic can be intelligently managed, and how you can build a security over this DNS layer, and how organization can leverage the DNS layer as a strategic infrastructure instead of just a passive infrastructure. So that is what we'll be discussing about in our today's Cloud DNS 101 session. Now, moving on, before we start about what is a cloud DNS and what is an like edge-based DNS, let's start with a small refresher. Let's understand what is DNS, and then let's understand what is an authoritative DNS in our context when we talk about DNS in real-world scenario. Now, DNS is the very first thing that happens whenever a user goes for any like accessing they access any web application. For example, they are trying to reach to an application. What happens is that before establishing any DNS connection, any TCP connection or any TLS handshake, DNS is the first things that happens whenever they're looking up for an application. Then only the TLS handshake will get completed, or the TCP handshake will get completed. So DNS runs at the first level. So that is why DNS is a very crucial aspect in an internet architecture or in a generic architecture altogether. It act as a backbone and act as a complete underlying mechanism for any application to be accessible across the globe. So if this DNS service is unreachable, or if this DNS service is broken, what happens is that the complete application becomes invisible to the internet. So the complete service gets disrupted, due to which the financial loss or reputation loss falls upon any organization. So that is why DNS is a very crucial entry for any application. So but the problem is that most of the large scale enterprise organization overlook this underlying architecture. Now, how when DNS lookup happens is that whenever, let's say, for example, a user is clicking on www, or a user is typing www.example.com in his browser, or a user receives a link over his WhatsApp, or it's in his chat, if he clicks on it, what happens is that usually the first level, what happens is that the user endpoint itself, whether it is their mobile, or whether it is their laptop, whether it is a desktop, in that endpoint itself there will be a local search. So basically the browser will search inside locally whether there is a cached information within itself for that specific domain, let's say www.example.com. If it doesn't find any information regarding the domain within itself locally cached, what happens is the request goes to the DNS resolver, or you could say the recursive resolver. So usually it will be your ISP provider, or for example, for example, you're accessing it from your home network, means it will be your ISP provider, or if are accessing it from your organization network, mean it might be your local DNS resolver server, or it can even be a public resolver server, for example, Google server 8.8.8. So the request falls through the DNS resolver. The user request again falls to the DNS resolver. It will basically ask what is who's www.example.com. Again, the DNS resolver also will search inside its cache, see if that information is available within itself. If not, the next thing what the resolver does is that, so resolver start querying the DNS within the DNS hierarchy. So the DNS hierarchy, the first hierarchy is the root servers. The root servers information will be actually already preloaded within the DNS resolver. So whenever any organization or anybody is setting up a DNS resolver, they'll preload the DNS root servers information in the DNS resolver. So the DNS resolver can know who are the root servers. So the query will go to the first hierarchy, which is the root server. But the root server will inform the DNS resolver that it doesn't have the full information of the specific domain www.example.com. Instead, it will send a referral saying that it knows who's the TLD. Basically, it knows the .com zone's information. So the DNS resolver will again do a query towards the next hierarchy in this flow, in this DNS hierarchy, which is the TLD zone. Under that, it will fall to the .com's TLD server. So again, the DNS resolver will do a query. Basically, it'll ask who is www.example.com. So if again, the TLD will say that I'm not the authority for this www.example.com zone. Instead, it will say I know who's the name server authority. Basically, who's the authority for this example.com zone. So it will give the name server address of the authority DNS. In maybe it might be ns1.example.com. Let's say, for example, it is ns.example.com, which is the authoritative name server for www.example.com. So this authoritative name server is the final source, or you could see the actual source of the information. This is from where the organization manages their information, DNS information. So this is where the organization controls their DNS information. So finally, the DNS resolver will send a query to the authoritative DNS server asking who is www.example.com, and the authoritative DNS server will finally respond back with the record. Let's say they're looking for an A record, which is nothing but the IPv4 address. So DNS authoritative DNS server will respond to it with the IPv4 address, public IP address to the DNS resolver. The DNS resolver will cache that information, and then it will answer the first query, which was raised by the end user. And then consecutively, what happens is that whenever a new users look up for the same address, www.example.com, and that DNS query is falling to the the same DNS resolver, the DNS resolver now has the cached information of that specific domain, www.example.com, with itself until the TTL get expired, which will be configured at the authoritative DNS server, which the organization manages. They will implement that TTL value until the time period gets expired, let's say 5 hours or 30 minutes. Until the time period gets information, the DNS resolver doesn't have to go again do the same hierarchical querying. Instead, it can directly answer it from its cache itself. So then consecutively for the next 30 minutes or the next 5 hours until the TTL get expired, then a new user's request, whenever it is falling onto the DNS resolver, it will directly fetch the information from the cache and answer to the user. So this is how, in general, a DNS lookup or a DNS process happens over the internet. Now, what happens if an authoritative server or the authoritative DNS server becomes unresponsive? If an authoritative DNS server becomes unresponsive, the complete chains goes down, and the complete application is invisible to the internet. So that is why it is very crucial to protect the authoritative DNS server. Now moving forward. Now let's talk about the registered DNS and how it becomes a liability for a large-scale enterprise when a large-scale enterprise organizations are using a registered DNS service. And registrar DNS service was originally built for bundling all the domain registration, domain management all together in a single, you could say a single solution, or you could say single as a single feature for end user convenience. So registrar DNS service was not built for an highly available architecture or highly available infrastructure, and registrar DNS never took into consideration that like large scale applications or large scale real time applications will be using or will be leveraging their services at you could say at the backbone level, or I could say at the foundation level. That is why registrar when we talk about registrar DNS, they are like basically built for simple record creation and management. Basically, what you can do at any register DNS provider, you can simply sign up, you can purchase your domain, and you can create a simple record, a record, or IPv4 record, or an IPv6 record, pointing it to your end destination. Simple as that. Like I mentioned, it was never built for an high availability protection workloads, or it was never built for intelligent traffic management or any security mechanism or any visibility mechanisms was not built within the registered DNS services. Or even when we talk about SLAs as well, register DNS services was not built around SLA metrics for like maintaining the performance of the service. Moving forward, there is one more deep problem. When we understood that registered DNS service was not built for with security in the mind, or availability in the mind, or performance in the mind. One more key problem with registered DNS is that registered DNS architecture is centrally sorry, I think I had an interruption. Registered DNS architecture was one more deep problem. Registered DNS has is that it is as a central architecture framework. So the registered DNS is centrally managed across a few different locations. So let's say if an Indian user, for example, from Bangalore or Chennai, is looking up an application which is managed through this registered DNS service, is looking up, for example, their application. What happens is that if the registered DNS service is managed in another continent or another country altogether, let's say, for example, Australia, what happens is that the latency for every single request is drastically increased, because whenever, if you remember the DNS architecture flow, the DNS resolver doesn't have that information within itself cached within its environment. It looks up that information with the actual authoritative DNS server. Now imagine if that inquiry is if that authoritative DNS server is managed in any different country altogether, let's say for example Australia, the end user request eventually will end up going to that specific country, and then the answer will come back to the DNS resolver, and DNS resolver will cache it and then give back that answer to the end user. So this becomes a complete huge overload, or you could say the latency has increased for the DNS query. So that is what first problem when we talk about having in central operation instead of having in decentralized or distributed architecture. So this is what the first problem of a centralized architecture. Second problem is that because this is a centralized architecture environment, this can be easily like any impact against the central architecture can impact all the customers who are using that service. For example, let's say there is an attack against that specific service provider, or if there is a disaster happened, if that production, that complete service goes down, because this is a managed with a central limited environment, that is getting impacted across all the other customers who are managing their service through the central registered DNS service. So that is also one other major problem, where they don't have this high availability mechanism inbuilt within them, and they don't take into consideration of the security mechanism as well. So these are key problems or key gaps where the central registered DNS service providers are having. Now let me hand over this presentation to the next speaker, our guest speaker, Mr. Dheeraj, who has built our VergeCloud Authoritative DNS service, or HPOPs, across India.
Thank you, Asad. Okay, let us discuss how reliable and faster are edge cloud DNS? Next slide, please. Okay, so here we are trying to show you a comparison in which on one hand, on the left side, you see your DNS is present somewhere in a central location. The right side, you see it is much more distributed all over the globe. So suppose you are a customer trying to operate globally all over the world, or maybe within a country as well, but you have a much more broader audience spread throughout the country. In that case, having a DNS sitting only in one place is single point of failure. All the requests will go and hit that particular DNS, and it will take time to serve the faraway users, as there will be more uh, TTL involved, and the turnaround time, the latency, what we call it, will be higher for the users that are not closer to that DNS. But in case of edge DNS, like VergeCloud has deployed and offered, you will have the DNS service running on all the POPs that they have deployed. And since your DNS, authoritative DNS, will be present closer to the end users, the resolution time will be much lower and you will see a better performance. Talking about the reliability, all the POPs in VergeCloud are running the DNS service. So even if you see one POP going down, the other one will kick in and your users will not see any kind of disruption. Next slide, please. Thank you. All right. So VergeCloud is using Anycast architecture, in which we use single IP, which we hand out to the end user as the DNS or authoritative IP. And the user does not have to worry about the IP changing every time. And so does the customer. So even if you want to, update your firewalls one time, and you don't have to worry about updating IPs, changing IPs again and again. So Anycast architecture helps in that. And since it is, as I said, India, if we talk about India market, it is very well covered with all our POPs. One POP is say 20 ms or 30 ms away from the other one. And if there is a failover, it is very quick and you don't see a latency difference coming in to play. For suppose your North Indian users are getting mapped to somewhere in Delhi or Noida, and you see Noida POP going down, then we have backup POPs in the same location and some POPs in a very nearby geography as well. And BGP helps to hand out the nearest POP IP. If there is a failover, there's a link failover, there's a POP failover, or a server fails or a POP fails. So everything is covered already in this architecture. Next slide. Okay. We have put up this diagram to show you a comparison on how a centralized DNS present in one location will look on the performance side, the latency, and compared to a edge Anycast DNS. So you see the black line, that is a flat line, more reliable, more predictable. So it gives you a much better picture of the performance as compared to the centralized DNS. So you see region 1, 2, 3, 4, 5. So 4 is clearly showing you that, okay, centralized DNS is present somewhere in region 4, and the users are getting somewhat okayish latency for that. But the users in other regions are not getting a very good performance, and it is not at all predictable. And it will cause a lot of frustration to the end users, and it will cascade to your customer, and customer might come back to you saying that there's a bad performance that they are seeing on day-to-day basis. Whereas the VergeCloud approach of having DNS, the authoritative DNS on the edge, you see that flat line. Even if there is a disruption, it will not spike much, and it will give you a much better more predictable performance. Next slide, please. So this is our India coverage of all our POPs. And as I mentioned before, that all our POPs have our CDN services, DNS services, as well as the security services. So all our POPs are full POPs. There is no bifurcation that we have DNS hosted only in the metros. It is present in tier 2, tier 3, tier 1 cities. So if you are a new business operator who wants to operate some applications or platform in tier 2 or 3 towns, we have got you covered. And yes, we will also be showing you a snapshot later at the end of this presentation on how we are doing on the DNS performance in India. Thank you so much. I will give it back to Arshad.
Thank you, Jiraj. Now, let's talk about the advantages whenever an organization starts using an cloud DNS services, or to be precise, an edge cloud DNS services. The first advantage an organization will have it, basically they'll be able to intelligently steer their traffic using the DNS layer itself. So DNS layer will now actively participate in traffic management. So that is what first we'll understand, the first advantage. So the DNS will act as an active control plane where the users will be able to decide how the traffic can be distributed. So the DNS platform now, once an organization started using Cloud Authoritative DNS services or Edge Cloud DNS services, now the team which is managing their applications, their engineering team, their DevOps teams, or any operation teams who's managing the application, now exactly they can precisely control how the traffic can be distributed across multiple different workloads. For example, let's say in this case, in this example, for example, let's consider this is one application, www.example.com. We'll be able to create multiple different records, saying that prime and define weightages for each records, saying that my traffic has to be primarily go to my primary data center. If there, let's say, load, you can even do a load sharing. You'll be able to define, let's say, 70% load on my primary data center, the next 20% load on my cloud workload for the same application, or then other remaining 10% can be for the next workload. So that way, traffic can be intelligently managed through the Cloud Authoritative DNS service. And now this pretty much allows the organization to have an highly scalable application, even through the DNS layer. Now, instead of the DNS is acting as a passive mechanism where we don't have control, or organization doesn't have any control over it, actively the organization can completely take control over it, and they'll be able to reliably manage their applications through even the DNS layer. So that is what the advantage Cloud DNS provides for any organizations. So these are some strategies they can implement to do that. They can use round robin mechanism where they can evenly distribute their loads across multiple different origins or multiple different destinations, or they can use a weighted routing mechanism where they can define for a specific destination the load can be in the higher side compared to the other destination. The second mechanism they can leverage when we talk about intelligent traffic steering. And finally, even they can even leverage global routing mechanism or global proximity mechanism, the other name for it. So basically what happens is that we can make sure that Indian user traffic, for example, is only falling within the Indian data centers or within the Indian origins, the destination, not going to a different origin, not going outside the geographical location. So that kind of smart intelligent traffic steering can be achieved through the DNS layer. So this is the first advantage an organization can achieve, having an edge authoritative DNS service where they can intelligently control their traffic or steer their traffic. The second thing they can implement at this DNS layer is that the security layer, security mechanism. The reason being is that DNS is not just about performance and reliability. It's a major attack surface where attackers focus their attack on. So let's say how now let's talk about how its DNS service providers or its authority DNS service can implement a security mechanism which can mitigate a volumetric DNS attack and prevent spoofing and DNS cache poisoning attacks. Now, like I mentioned, DNS is an primary, or you could say, and highly attacked surface for by any attack, like any malicious actors. So DNS has become and layer where which easily an attacker attacks them, and they can disturb any services, because as I earlier discussed about, DNS is the underlying mechanism anyway through which any application can be accessed over the internet. So if this layer becomes disrupted or it becomes unavailable, the application itself completely goes invisible. So that is why an attackers generally focus primarily at these DNS layers. For example, they use DNS flooding attacks or UDP amplification attacks. So these kind of attacks can be used to target the DNS layer, and these through this mechanism they will be able to take down the DNS services. If now consider now if think about if an organization is using a centrally managed registered DNS service, this becomes a single point of failure. So that is why DNS is a crucial attack vector for for any attackers. So they primarily focus on these underlying architecture to completely take down the application. Even if the resolver is still up and running, it doesn't matter, because the authoritative DNS services or that name server goes down. If the name server is getting targeted and it goes down, the application itself, whether it is active or the application origin is active, it doesn't matter. It's still the application won't be able to, users won't be able to access the application. So this is one crucial layer where attackers primarily focus on. Now, how an edge cloud DNS service architecture itself prevents these kind of mitigation attacks, in these kind of volumetric attacks, DDoS attacks. Because our architecture is decentralized architecture, that itself, and an Anycast architecture, that itself has become an way through which we'll be even the attack traffic will be evenly distributed across multiple different POPs. So our POPs won't get bombarded because of our architecture. All the traffic loads will be evenly distributed across multiple different POPs. So this is the first level we'll be able to mitigate the volumetry attacks. The second thing is that at our edge POPs, we have a DNS mitigation mechanism in place to prevent DNS flooding attacks. We implement those security engines to mitigate these kind of UDP amplification attack or distributed DNS attacks. So these are some mechanism we have implemented at our service to prevent DNS flooding attacks. First advantage is because of our architecture. The second thing is that we have inbuilt DNS mitigation mechanism to prevent DNS flooding attacks. And top of it, to prevent DNS spoofing attacks, we have DNSSEC enabled at our authority DNS service. What DNSSEC basically does is that it will make sure that attackers are not spoofing or not acting as the authority DNS service. So it can validate the authority DNS service. So that is what the DNSSEC mechanism is. This is part of our authority DNS service. So basically, what the DNSSEC will do is that it will first sign all the response from the authoritative DNS service using the public key exchange mechanism. So basically, it has a concept called DNSSEC. DNSSEC. So that DNSSEC has something called as DNS key. So through this DNS key, all the records, all the A records, all the DNS records will get digitally signed. So whenever the DNS resolver is receiving that information from the authoritative DNS service, along with the answer of the record requested for example, let's say your user is requesting for a record, along with that record, the DNS key also, or the signed RR-SIG record, we call it as RR-SIG record, also comes along with that request. That will be validated at the DNS resolver level. So this way, we'll be able to prevent DNS spoofing attacks. So, and the next thing what DNS can help in is that it can implement a trust validation. Basically, from the root level, if you remember the DNS hierarchy, which I was talking about, from the root level till the authoritative DNS server level, we'll be able to implement a chain. you'll be able to do a chain validation from the rule to the authoritative DNS service. The third thing the DNS sec can be used for is to even we can mitigate or we can prevent DNS cache poisoning attacks through the DNSSEC service. So these are the mechanism or DNS. These are the security mechanism you can implement at the authoritative DNS service. First thing is to prevent volumetric DNS attack, and second thing is to implement DNSSEC to prevent spoofing attack, DNS spoofing attack, and DNS cache poisoning attacks. And finally, to summarize and to talk about key takeaways. So what is the advantage any organization can get whenever they start using Edge Cloud DNS Authoritative services? That first thing is that they'll have a reliable performance because of the architecture level. Because our architecture is Edge architecture is a distributed architecture where we are not centrally hosted across in small regions. We are distributed across different regions, due to which the performance is very compared to the central architecture solutions. The second thing is that our resiliency is in the highest level due to our distributed architecture, because we don't have a single point of failure, because we are using the same IP Anycast architecture. We are broadcasting the same IPs to all our end users. So even when one location, if there is an issue, the users will be able to go to the next edge pop without even noticing it. That is how resilient our solution is. So our edge authoritative service is highly available. We have that resiliency part of our architecture, inbuilt part of our architecture itself. The third thing is that we have a security mechanism inbuilt within the edge service, edge cloud DNS service. Like I talked about earlier, we have DNS mitigation engine, which will even prevent DNS flood attacks, UDP amplification attacks, and we have DNSSEC mechanism part of our cloud authoritative DNS service. This will be implemented to prevent DNS spoofing attacks or DNS cache poisoning attacks. And finally, through Edge Cloud DNS architecture, an organization can intelligently manage their traffic. So they pretty much can use the DNS layer as an active traffic steering mechanism instead of using it as a passive layer. So these are the key advantages any organization will have when they start using Edge Cloud DNS services. And before I conclude, just to summarize, or let's say just to talk about our VergeCloud Edge platform, we don't only do a cloud authority DNS service. VergeCloud provides like an holistic edge solution. We provide DNS protection against the origin. We implement, which I talked about, cloud authoritative DNS services for our customers. We provide that. We provide layer 7 firewall capabilities for any applications. We provide bot mitigation solution for any customers. We provide delivery functions for our customer through leveraging our caching features. Plus, we provide WAF functionalities for any customers. On top of it, we have edge functions also as part of our edge pop services. So edge pop function is still in the testing phase. We can expect that to be available for our customers from end of this quarter onwards. So our Verge Cloud solution is an holistic solution where not only we are providing authoritative DNS service through the cloud, we are providing the complete secure edge stack for our customers. Thank you. Now let's go to the Q&A.
Thank you, Arshad, and thank you, Dheeraj. That was quite informative. And we already, there are a lot of questions that has been posted by the audience. I see that it has been addressed already by Dheeraj. Let us see if there is any that has been missed from being addressed. Dheeraj, would you take this question? Sashi Kumar has asked, during a DNS flood attack, how does the infrastructure know the difference between a genuine traffic spike and malicious query volume?
Right. Okay, so Shashi, in this case, we have historical context of how many requests per second or packets per second we were getting previously for any given customer. And keeping that in mind, if there is a baseline difference that we see, say by 20% hike or a 25-30% hike that we see, our systems are intelligent enough to alert us about that. And same is communicated to the customers as well. So it is more of a historical context that we compare with the current one, and also the traffic pattern on daily basis, or comparing it over the weekend as well. So you might see that during normal days there is a high traffic over the weekend, but then if there's an attack, you will see similar pattern during the weekdays as well. So that can be also one of the indicators that we take into the consideration. And then there are a lot of algorithms at play that figure out that, okay, requests should be coming in only from India, but they are coming in from some other countries. That is one of the indicator other than the traffic levels. And then any sudden spike, as I mentioned, you will come to know that or is it coming from a distributed source. So yeah, you want to add something, Arshad? Please go ahead.
Yeah, basically what I was about to say is that earlier we mentioned that we'll be sharing, showing our DNS performance metrics. Just want to show that before we go to the next question. If you're okay with it, let me share that. I hope my screen is visible.
Yes, Arshad.
So this is one of way you will be able to see the DNS performance across the globe, which is through dnsperf.com or DNSperf. So basically, if you notice in India region, we are in the top when we talk about DNS query speeds. So this is one of the reason why we are having this query speed is because of our architecture, because of our distributed across India region. So we are making sure we are always in the top charts when we talk about the performance. So just want to show this to our audience because we forgot to include this snapshot in the deck. That is the reason I'm just showing you this. Any other questions which is not yet answered yet? Let me go through it.
I think all, if you have any other questions, please feel free to drop it in the chat box. But thank you, Dheeraj, for addressing all the questions already. And even if you come up with a question later, please feel free to write us at sales@vergecloud.com. I'm just sharing the mail ID in the chat group, and we'll make sure to answer your questions post the webinar as well. All right. I think with this, we come to an end of the webinar. And thank you, everyone, for joining today. And we look forward to staying in touch. Thank you, Dheeraj, and thank you, Arshad. Have a good day.
Thank you. Thank you so much. Have a good day. Thank you, everyone, for joining the session.